In this video, we're going to learn how to factor trinomials. So, these examples are all trinomials. That means that there's three terms, and they're all written in standard form. They're all written from highest exponent to lowest exponent, and they're all sorted by variable. There's only one variable in each of them, so, but they're all in standard form. So when you factor a trinomial, there's three things you should try. One of them should work. When you factor, you should always check to see first, can you use greatest common factor? Is there something that you can divide out of each term? So in this, there's no greatest common factor in terms of x's, right? Because there's no x there. And there's no number that can divide evenly into any of those. So GCF's not going to work on that one. Let's check here. 3, 16, and 21. The GCF of those three numbers is 1, so that's not going to work. And again, there's no x here, so there's no GCF in this one. And then this one, x squared minus 6x minus 16. They don't all have an x, and the GCF of the numbers is 1. So you should always check first to see if the problem can be factored using greatest common factor. And then you should check to see if you can use difference of two squares factoring. Now, we haven't talked about this yet, so spoiler alert, none of these are going to be difference of two squares. But for it to be difference of two squares factoring, it needs to be a binomial, which none of these are. It needs to have a minus sign in the middle, which, I mean, that one kind of does, but it's not a binomial. And every single thing involved has to be a perfect square, which 16 is a perfect square, right? But none of these are difference of two squares factoring. Only after you check that both of these things are not possible are you going to actually do trinomial factoring. You should only do trinomial factoring if the other two can't be done. So anyway, let's do trinomial factoring on this. X squared plus 12x plus 32. So this can be factored using box method. Let's look at this for first term here, x squared. What do I have to write here and here to multiply to get x squared? There's only one way to multiply to get x squared, and that'd be x times x. Right? X times x is x squared. Now let's deal with this term, the 32 here. If we put a 32 there, what could we multiply to get 32? Well, there's a few options, right? There's 1 and 32, and 2 and 16, and 4 and 8, and that's it, right? So we need the numbers that we picked to add up to 12x, right? So if I put, oh, well, there you go. 4 and 8 is 12, right? So if I put 4x there and 8x there, what did I multiply x by to get 8x? I must have multiplied by 8, right? And what did I multiply x by here to get 4? Well, that's 4, right? And 8 times 4 is 32. So our final answer here, to finish the factoring, we're just going to write these two things here, these two binomials, like that. So this right here is the factored version of that. And you can hear when I was doing that, it was really just guessing and checking, right? There wasn't a ton of math that needed to be solved. It's just guessing and checking. So let's try another one. Let's factor this. We already know that it's not GCF and it's not difference of two squares. So let's do a box method here. Let's start with this term, 3x squared. The only way to multiply to get 3x squared is to do 3x times x, right? I know you're thinking maybe 1.5 and 1.5, but those actually would multiply to 2.25, right? So the only way to multiply to get 3x squared is 3x and x. Now we need this number to be 21, right? There's only two ways to get 21. That's either 1 and 21 or 3 and 7. Now the issue with this one is this one just had an x squared. This one is a 3x squared, right? So the order of these is going to matter because one of them is going to be partnered up with this 3x here, and one of them is just going to be partnered up with an x there, right? So actually, there might be 4 options, right? Depending on where we put things. So I'm just going to kind of write it small. I'm going to put 7x there, and I'm going to put 3x there. Now, if I put a 7 there, 3x times, see, that wouldn't work, right? So what we need to do here is try maybe the 7 here, because 7 times 3 is 21, right? That's not going to work, right? So a 7 doesn't work there. Let's try a 3 there. 3 times 3 is 9x. And then if we put the 7 there, 7 times x is 7x. Do these two numbers, 9x and 7x, they add up to 16? They do, right? So 3x times x is 3x squared. That's that. 7 times 3 is 21. That's that. 7 times x is 7x, and 3x times 3 is 9x. These two add up to 16x. So our factors here are x plus 3 and 3x plus 7. So again, it's just guessing and checking. You just got to try all your options. If it helps, list out all the ways to multiply to get the number you need, and then just kind of start throwing numbers in and see what happens. Okay? Last example for today. X squared minus 6x minus 16. This is an x and this is an x to get us x squared. Now we need two numbers that multiply to negative 16. So we have 1 and 16, or 1 and negative 1 and 16, or 1 and negative 16. We have 2 and negative 8, or negative 2 and 8. And we have 4 and negative 4. That's everything, right? So there's 5 options here. We need them to multiply to be negative 16. So if it's multiplying to be negative, that means one of the numbers is negative. That's why I listed it like that. And we need the numbers that we picked to add up to negative 6. So it looks like these two right here, 2 and negative 8. 2 times x is 2x, and x times negative 8 is negative 8x. Do these two numbers multiply and add correctly? Excuse me. Yes, they do. So the two factors are x plus 2 and x minus 8. All right, so trinomial factoring is just working backwards. I'm giving you the answer to a box method problem, and you're using box method to work backwards and try to get what two things that you multiply to get that. You're trying to come up with the two factors that you used. All right, so that's it for today. Thanks for watching.